Everyone, welcome. Hello, welcome to Simulation. How are you guys doing? Good. Yeah, ooh, there's that energy. Let's get a little bit of that good energy in here. Yeah. We love the Battery. This is an amazing venue, and you guys are really great people. We know lots of people that are members at the Battery, so this is a privilege and an honor to be here right now and featuring a show here. Have any of you been to one of the Simulation live events before? Yeah, we have a couple, yeah, but mostly no. Okay, so Simulation is a daily show and live event series. We feature some of the greatest scientists, entrepreneurs, technologists, educators of our time. And we really love the power of really thought-provoking questions. And how are we going to guide the future of humanity? And so we see, sports stadiums filled with 22 football players, and we're like, how about we fill it with curious intellectuals? Does it sound like fun? Yeah, let's see if we can get there and do that. So that's a little bit about us. So the guest, are you guys excited for Dr. Aubrey de Grey? Yeah, we're really excited for Aubrey. Yes. He's an author, biomedical gerontologist. He's a chief science officer at SENS, so the Strategies for Engineered Negligible Senescence. He's also the VP of New Age Discovery Therapeutics. And we are really excited to feature him. We're going to be talking about rejuvenative medicine and the roadmap to end aging. So without further ado, introducing Dr. Aubrey de Grey. Woo!
Thank you.
Aubrey, thank you for joining us. I think this is show number 4 or 5 together. We've done a couple shows together. And it's been a pleasure every single time. I always learn more and more about your work and about kind of where we stand on this major goal that you call it the pro-aging trance, that everybody thinks that aging is totally okay. And
Yeah. I mean, I was having a nice chat with some of your friends over dinner just now about that. One must have to work really hard to persuade oneself that aging is a blessing in disguise. I mean, honestly, So you've got to engage in a hell of a lot of really energetic self-deception, and I think it's a trance.
And you're working on rejuvenative medicine to end aging, and you have been for quite a while. This is now, how many decades in are you?
Well, I guess I switched from being a computer scientist to being a biologist something like 22, 23 years ago. I think, we could say that I've been working in, actively in actually, sponsoring research and so on for about 15 years. So it's quite a lot.
That's a long time. That's almost as long as I've been alive. Yeah. I should have said I'm Alan Saki and I host the show. And Aubrey is, as he's saying here, he's done this 23 years and switching from computer science, which also gives you a very interesting sort of spin and take on understanding things.
Very useful it was, yes.
Yes. And you say that the aging is not a consequence of biology, but rather physics.
Well, so let's talk about that. So people, the fundamental problem that I think helps people to maintain this ridiculous pro-aging trance is they continue to believe that aging is a mystery. There's some kind of utterly enigmatic phenomenon that nobody understands at all, which is complete nonsense. And the reason I make this point about physics, and in particular the reason I emphasize that aging of a living organism is pretty much indistinguishable from aging of a simple inanimate machine like a car or an airplane, is to demystify it. To emphasize that decay is something that naturally occurs as a result of the normal functioning of any machine that has moving parts, but naturally is not the same as inevitably. So in just the same way that we can compensate for the accumulation of damage in a car or an airplane by periodic, comprehensive, preventative maintenance, similarly, we have absolutely no reason to doubt that we can do the same thing for the human body. It's just that it's harder because the human body is more complicated. And of course, the natural reaction to that is to say, well, yeah, I mean, that is the point, isn't it? The human body is astronomically more complicated, therefore this hypothetical preventative maintenance is astronomically more complicated, therefore we might as well forget it because we won't actually ever be able to do it. But that turns out not to be true when you look at the details, and that's where everything that we do at SENS Research Foundation has come from.
And there's 100,000 people that die per day for aging.
This is right. It's actually around about 110,000 now. I mean, actually, that's a remarkable thing. So the first time I did those numbers was at least 15 years ago, perhaps a little longer. And yeah, I came out around a number pretty much exactly around 2/3 of all deaths worldwide being due to aging. In other words, being due to causes that pretty much never hit people who are in early adulthood. And you know, that's shocking. And of course, it's even more shocking if you restrict yourself to the industrialized world. You're up around 85 or 90%. But what's even more important to me is that over the past 15 years, those numbers have been shifting upwards fast. So it's almost up around 3/4 of all deaths now. It's well over 70%. It's astounding. You know, at this point, according to the most recent statistics, there isn't a single country in the whole world whose average lifespan is below 50, even like sub-Saharan Africa. If you exclude sub-Saharan Africa, then it's the bottom one is over 60. So, you know, aging is not just a first world problem. Absolutely not.
Mm-hmm. You're also very good at making the content relatable. And as this happens, you become a professional at what you do 23 years now, you make this very clear that metabolism causes damage, which causes pathology over time. And you make this analogy to a vehicle, tweaking a vehicle over time, and that repair process can keep a vehicle operating longer. And so what are sort of the tweaks that we're working on internally for our own bodies? Yeah.
Yeah, thank you. I mean, you're quite right. I think this is something that I've gravitated to as an extremely effective way of helping people to understand what's going on here, dividing the process of aging into two processes. Firstly, the creation of damage as a consequence of the machine's normal operation, whether it's a human body or whether it's an aeroplane or whatever. And secondly, the decline in function of the machine that results from having more damage than the machine is set up to tolerate. There's always a certain finite amount of damage that the machine is set up to tolerate, whether by human design in the case of cars or whatever, or whether by evolution. But it's a finite amount, and once you get beyond that, things start to go downhill. So dividing it into those two categories helps a lot. It helps especially in order to explain that preventative maintenance really is all we need. It really does give us the ability to keep the level of damage below that threshold so that we never get the decline in function that we would normally see. Mm-hmm. And then, of course, the specifics matter. Mm-hmm. Just in this, of course, the specifics should not necessarily matter to you guys in the same way that you don't really care exactly what your car mechanic does when you take your car in, right? You just you just care about the result. But at the same time, because we can't do it yet, you kind of do want to know a little bit about the details because you want to know how realistic it is that we'll actually get them working fairly soon. So yeah, I mean, it's things like stem cell therapies, various uses of gene therapies to repair and augment the genetic capacity of our cells to repair themselves, or to kill themselves when they're not wanted. That's actually an important part. Then immune therapies, tweaking and optimizing the immune system to work better against things that it already works a little bit against, but not well enough, like cancers. You know, these are the kinds of things that we do. But the ultimate goal here, the ultimate like 40,000 foot level, is all about restoring the structure of the body to how it was at an earlier age. Structure at the molecular level and at the cellular level. If we can do that, then kind of by definition, we will restore function at the same time. Because at the end of the day, however complicated a machine is, and however poorly we understand the way that it works, its function is determined by its structure.
Okay.
Hang on, what did I say there that was even slightly challenging?
No, not. Oh, I'm just on a roadmap to end aging. There's nothing challenging. There's. Okay, so we have okay. The way we feel when we're very young, we feel like we can take on the world, and then these sort of ailments occur to us over time, and then
Yeah, speak for yourself.
Aubrey, you still feel like you're 15 sometimes?
Most of the time.
Most of the time?
Yeah, you're as old as the woman you feel, right? You know that one, right? The woman I feel is 48, I should point out. I mean,
okay, so you take we take technologies like stem cell therapy and gene therapy, and how do we scan the body to figure out where the pathology is occurring?
Well, okay, so that's actually a really important question for a reason that's a little bit counterintuitive. It's probably not going to be very important to do any scanning. And the reason it's not is because we all have the same kind of damage. The reason this is counterintuitive is because, of course, we're all familiar with the fact that different people in old age get different problems. You know, some people die of cancer, some people die of heart disease, and so on. But it turns out that if you take into account, if you start from what I just told you about how these problems only emerge when you've got more than a particular threshold tolerable amount of a particular type of damage, or a range of types, then it turns out that this variety in what goes wrong with us is kind of an exaggerated image of what's really going on. What's really going on is that we're all accumulating the exact same types of damage, every one of us, all the time, since before we're born even. But there's small differences, just small differences in the rate at which we're accumulating different types of damage. So some of them get to an intolerable point a little bit sooner than others, et cetera, right? Now, what that means, of course, is that if we're attacking the damage, this precursors, which is what we're doing right here with preventative maintenance, and not attacking the consequences of the damage, the actual late life pathologies, then we don't need to worry about those differences. I mean, the worst that can happen is that we might end up giving people a damage repair therapy twice as often as they might need it. Who gives a damn, right?
And that won't have any negative consequences.
Well, of course, you have to, all medicine is experimental, right? You have to get to a point where you understand the safety and so on. But yes, I'm absolutely certain that it will be easy to get to a point where what's called the therapeutic index of these therapies is easily wide enough that there won't be such a problem, that it'll be totally fine. And because it'll be totally fine, it'll probably be a lot cheaper and more efficient and just more sensible to just give everybody the same stuff.
Okay, so then, and does this matter what age approximately we're getting
so that comes down to the question of the fact that these are damage repair therapies. They're bona fide rejuvenation. They will take people back to an earlier biological age than what they were before. So what that means is that it makes no more sense to apply these therapies to 20-year-olds than it would to take a brand new car into the garage after a year or after 6 months or whatever. You know, there's just not enough damage to repair. And it's going to be a long, long time before the damage does get to the point where there's enough to repair that actually justifies doing it. Plus, we have to take into account something that does not apply with cars, namely that we're still learning how to do this, and we will carry on perfecting these therapies, not only in terms of cost, but also convenience, comprehensiveness, safety, and so on, for a long, long time. So that means that the trade-off will be that it makes sense to wait until middle age. Yes, you'll have more damage to repair, but that's okay. It won't be bad for you yet. And also, the scientists will have had all that time to make the therapies that much better before they apply them to you.
I see this animation or this visual of the age slowly increasing and damage slowly accumulating, and then getting Aubrey de Grey to come over and bring my damage down and my biological age back down.
That's the idea.
And that's Okay, so this is around middle age is when we'll be
Yeah,
administering
well,
these?
yeah, maybe 50, let's say.
50, okay.
Yeah, I mean, very little goes wrong with you until you're 50. I mean, badly wrong. I mean, of course, it's perfectly fine to apply these therapies earlier if you happen to be an unlucky person, you know, if things are going wrong a little earlier. But, you know, 40, so what?
And then let's maybe dive a bit into the nitty-gritty nuance of the biology and the physics. So there are a certain amount of strategies at SENS Foundation, and maybe you talk to us about how you're actually applying.
Yeah, so very briefly. So the thing is, because the human body is so ridiculously complicated, we do unquestionably have a large number of different types of damage that accumulate in the body. But that isn't necessarily a problem. And I would say the single biggest breakthrough that I ever made scientifically back in 2000 was to realize that even though there's so many different types of damage, they can be classified. We can make a kind of taxonomy of damage. And in particular, that we can group them into a very manageable number of categories, just 7 categories. The utility of this classification is not immediately obvious, but let me explain what it is. The utility is it defines the strategies for intervention. So for each category, within each category, there may be lots and lots of different examples of types of damage, but all of them can be addressed, can be repaired in more or less the same way. To give you just one example, one of the 7 categories I started speaking about back then is loss of cells. Cells dying and not being automatically replaced by the division of other cells. Very simple concept, and sure enough it happens. And indeed it happens in a lot of different types of cell, in a lot of different parts of the body. But in all of those cases, the fix is basically the same thing, stem cell therapy. You just put cells into the body that you have pre-programmed into a state where they know what to do, to divide and to transform themselves into replacements for the cells that the body is not replacing on its own.
And the body naturally accepts this?
And of course, there's lots of trickery that needs to be involved, which is why this is not necessarily working yet. So, for example, back in 2006, several years after I mentioned this as one of the key strategies, there was a huge breakthrough that pretty much entirely solved exactly that problem. Namely, the ability to create stem cells of pretty much any type you like from cells that were not stem cells in the first place. In other words, cells that you could take from the person that you were going to give them back to. So you would take a cell that wasn't even a stem cell at all, you would what's often called de-differentiate it, turn back its developmental clock to a very primitive state, and then take it back out again, whatever direction you wanted, to create the kind of stem cell that was needed for the problem that the person had. And because it was originating from the same person, and therefore had the same DNA, it would be accepted. So that's just one part. And back when I was talking about all this originally, that hadn't been invented yet. So it looked like it was a much harder problem than it actually would be now, right? But still not hard enough to be impossible, right? So these are the kinds of things that's happened. One of the most gratifying aspects of the work that's happened over the past 15, 20 years, since I've been talking about this and thinking about this, is that all of the surprises, the scientific surprises we've had, have been good surprises like that. We haven't had one single case of a bad surprise. There are 2 kinds of bad surprises that could have happened. One is we could have come across new types of damage in the body that didn't fit into my 7-point classification, and therefore we had to come up with a whole new, different way of addressing it. That hasn't happened. The other thing that could have happened would be that one of the existing 7 categories, the approach that we were going to use to address it, we found out some reason why it wouldn't work. That also hasn't happened. So, you know, it's all looking pretty damn good right now.
And some of these other classifications, maybe briefly?
Yeah, all right, where shall I go next? Well, let's take atherosclerosis. So atherosclerosis is, of course, the #1 killer in the Western world, causes heart attacks and strokes. And it happens because white blood cells, a particular type of white blood cell called a macrophage, they don't know how to destroy a particular compound, or a particular family of compounds, but there's really only one that matters the most. These compounds are oxidized versions of cholesterol. So you all think cholesterol is a bad molecule, but it's not. Cholesterol is an absolutely essential molecule. If we didn't have cholesterol, we'd be totally fucked. But it spontaneously gets chemically modified in the body into various forms that really are bad for us. Now, those bad forms are only present at much lower abundance, much lower concentrations than regular cholesterol, but because they're bad for us, right? And in particular, the cells that are affected that really matter are these particular types of white blood cell. What happens is that those white blood cells are poisoned by this stuff, even though it's present at rather low abundance, and they end up doing more harm than good, basically. They end up putting out inflammatory signals, trying to get other cells to rescue them, who also can't because they also can't, they're also poisoned by the same stuff. And so that's where the growth of atherosclerotic plaques comes from. Now, none of this would happen if these white blood cells were able to destroy the toxic molecule, because obviously if you could destroy it, it's not toxic. So the question is, could they? Could we enable them to do so? And that's exactly what we succeeded in doing. The idea I put forward, and actually this was almost, it was late 90s I put this forward first, was to identify bacteria that have the genetic capacity to destroy an important toxic molecule. So they would have a gene that we don't have, okay? They would have a gene that allows them to do this. Now, they would, of course, not be doing it in order to avoid atherosclerosis, bacteria don't get that, but for some other reason. But that's fine, we don't care why they evolved this gene. The fact is, all that matters is they have it. And it turns out this works really well. You can find bacteria that can metabolize pretty much whatever the hell you like, just as long as you look in the right place. There are clever tricks for knowing where to look. So, sure enough, we were able to find bacteria that could metabolize these oxidized cholesterol derivatives. Now, we wouldn't want to inject those bacteria into the body, but that's not the idea. The idea is to identify the gene that they have that allows them to do this, and then put that gene into human cells. If we do that, then we're giving those cells the ability to break down the stuff that they would not otherwise normally naturally be able to break down. And it works. We were able to show, maybe 6 years ago, first key proof of concept paper we published on this, that this indeed works. And so we're obviously continuing to push this. It should be in clinical trials soon. There's a company now. So this is all going nicely. It's not just atherosclerosis. So again, to illustrate how this is just a case of classification of problems, there are other problems, other big problems, that are in the same category. So this category is basically molecular waste products that are created as byproducts of normal metabolism and that the cell can't destroy. Okay, that's the general definition of the category. Another example happens in the eye. The number one cause of blindness in the elderly is macular degeneration. And that's got nothing to do with cholesterol, but it's fundamentally the same idea. What happens is that there are cells at the back of the eye called retinal pigmented epithelial cells, which accumulate a molecule that's a derivative of vitamin A. And that molecule, again, it's only present at relatively low abundance at first, but it is completely resistant to any kind of degradation by the cell. So eventually it accumulates to a point where it's bad for the cell. And again, we've identified a bacterium, identified the genes, be able to put those genes into human cells, and it works. And that's going to be in clinical trials, probably this year, certainly within a year.
And this is the landscape of your strategies that you listed there, and then this is under SENS Research Foundation, a nonprofit, and then there's so many other for-profit biotech anti-aging companies that have come up, but the Buck Institute is also nonprofit.
Well, right. So there's very much a spectrum here. So as is true in any technology, there's a spectrum from concept to proof of concept to investment to product. It's just the same here. It's just the same in all of medicine, and this is just medicine. And we play a very, very important role at the SENS Research Foundation in this. We essentially are the bridge across the valley of death. The valley of death in the standard sense in which you have come across the term. The getting from concept to investment. And the way we do it is we identify the things that need to be done, which is obviously a very selected subset from the basic research, discovery-oriented community that's going on in academia. And we direct money, insofar as we can, in those projects, and we get them to a sufficient level of proof of concept where investors, at least the more visionary investors, more angel kind of people, are willing to get involved. It works. We have been able to, the two examples I mentioned just now of getting rid of waste products inside the cell, both of them have been spun out into companies now. And, you know, that's what we want to do. We've done it, if you look at all the entire spectrum of what we've done that 5 times now. There's another one coming next month or the ones after. You know, this is our business model now.
So they spin out into companies.
That's right. That's right. We create the company in one way or another. We transfer the intellectual property that we've generated into that company, and they run with it. And of course, this only can be done when investors are interested. But we talk to investors all the time about potential projects that could be spun out into startups. And one of the most heartening things about this is that the investors we're talking to, they tend to really understand our model. So they will very often donate as well as invest. Not only will they come and give, seed equity buy equity for seed money from these companies, but also they want to be the founding investor of the next company. So they will give us, respectable money, purely philanthropically, to the foundation. And what they get for that, of course, is access. Anyone who gives us a respectable amount of money, they can come and visit us whenever they like. And, they can talk to our scientists and they can hear about whatever we're doing. And it works. That argument is the investors are buying that argument. The financial situation in the movement right now, defined as both the non-profit and the for-profit, is a lot healthier than it was even a couple of years ago. But it's still got a long way to go. Do not get me wrong. There is no question that it remains the case that if there were just one more digit on the amount of money that's available to this work, whether at the foundational stage or at the startup stage, then we could be going 2 or 3 times as fast. In terms of, that's a hell of a lot of lives to be saved.
Yep. So how do the nonprofits, you gave the example of with SENS, you will spin off and transfer the intellectual property, and that company will go and start making money as well and become profitable. Okay, and then how about all these other spin-offs, the Calicos and Elysiums and all, yeah.
So yeah, it's quite a community. And certainly we're not the only ones spinning out companies. So the Buck Institute, which you mentioned a moment ago, they're a much more traditional academic outfit. They're also a non-profit. They're a fair bit larger than us, but they are larger than us because they've chosen to be much more mainstream. So there's a whole bunch of things they can't do, and especially things they can't say, that they would love to say.
What are some of those things?
Well, basically that aging is bad for you. They can't say things like that. They've got to say,
Wait, why is that they can't say it?
Because the majority of the funding that is received by the people that work at the Buck is public money. Either public money from the NIH and such like, or it's from foundations that are effectively the same thing. Essentially from places that have a constituency that is about as pro-aging hypnotized as you can imagine.
Okay.
Right. So they've got to be extremely careful about what they can say. Now, of course, I can speak to these people over a beer, and they'll totally, The reason why the Buck and SENS Research Foundation have such a close-knit collaboration, and we send each other people all the time, is precisely because there is this absolute understanding under the radar that we're all on the same page. But there's also the understanding that it is very valuable to have a good cop, bad cop kind of thing where different organizations which have an identical understanding of the right science to do nevertheless speak to different audiences and get money from different places. You know, there are people that give money to the buck that would never dream of even having lunch with me, and vice versa. You know, so it's the right way to do things. The hybrid nature of this movement is working well.
Yeah. That's strange that the people that are very deep in the pro-aging trance are in many cases giving money to Buck because Buck is keeping a different profile on things than you are. Okay, so how about the other players in the space? Kind of what differentiates?
Calico, so
yeah, what differentiates everybody?
Well, there's a lot of differentiators. So you know, there've been companies in the anti-aging industry forever. And of course, the fundamental difficulty with those companies is that they are, you know, their products don't work, and furthermore, that they make a lot of money anyway. So the whole movement gains a poor reputation. You know, when I was getting known early on, I definitely benefited a lot from the fact that I look a little bit unmaterialistic. It's very hard to persuade yourself that I'm into this for you know, personal financial gain. So that was useful. But also, you know, over time there have been companies coming along which have started with the best of intentions. Very often they have been started by prominent academics. So there was a company called Elixir, which was started by Lenny Garanti and Cynthia Kenyon. There was a company named Circus, which was started by David Sinclair, and there were companies before them. And these companies, you know, could, in principle, have done great stuff. But because they were companies, and because the people who started them didn't really know what they were doing, the result was they ended up being essentially taken over by short-termist investors and diverted into stuff that, again, didn't work. And so it was essentially a complete waste of time. So the lessons have been learned, and this is not really happening anymore. The companies that are happening now are kind of doing a bit better. Elysium is a little bit of a kind of halfway house in the sense that it probably had a little bit too much hype around it. You know, it does have a product after all already, and the product is perhaps, you know, not entirely proven. But you know, it's better than Elixir was. So that's progress.
Is anyone else doing the broad scale like you, or are there more specialty?
Well, broad scale doesn't really work in industry. You know, investors always want you to focus, right? So that's kind of another thing that we give to the world, to this whole ecosystem, that a for-profit company is in a more difficult position to do because we have a remit of being as broad as needed, right? Calico then. Now, Calico is, I've got to try and be not completely like unprintable about Calico. I don't think much of Calico. Essentially, Calico was created, and it's all Larry and Sergey's fault. It's not the fault of the people at Calico. Larry and Sergey just had a completely fucking brain-dead understanding of how to set up a company to fix aging. They thought, I don't know, we want a company because companies work and non-profits don't. Well, that was the first mistake. They could have given me lots of money and that would have been fine. I could have done it by now. But hey, okay, a lot of people make that mistake. You know, that was just the beginning. Then they thought, well, okay, what do? We want a company. Okay, it's going to be a biotech company. Let's hire the world's best biotech CEO. And they did. His name is Art Levinson. He used to run Genentech. He's absolutely the best. No question. But he actually hasn't got the faintest idea how to fix aging. Now, the good news is that he understands that he doesn't have the faintest idea how to fix aging. Fine so far. Unfortunately, the next step is hire someone who does as your chief science officer. And the problem is he also didn't know how to do that. So he hired the ultimate, you know, okay, what can I say? Suffice to say that the ultimate outcome has been that within Calico, there is their own internal valley of death. Right, they've got this research paradise where they'll discover stuff until hell freezes over, you know, and then they've got this Genentech Mark II over the other side, which will take drugs and market them really well, and they've got exactly nothing in between. It's a complete fucking clusterfuck. I mean, it could not be worse. And I have been, I've been saying this in print quite a lot, so it's okay that I'm now saying it on camera. But yeah, I mean, yeah, don't get me going about Calico in case you didn't, in case you thought you had. However, the rest of the ecosystem, which essentially consists of startups, small startups, well, I mean, Unity's no longer small, but yeah, mostly small startups. That's going fine. That's where I'm at. That's where I'm at. That's what I'm helping to spearhead. I spend a fantastically wonderful amount of my time now just making introductions between investors and investees. Just putting the right people in touch with the right people and getting money to flow in the right direction, getting the right work done. It's an extremely gratifying position to be in right now, and it really makes me feel, I don't want to say I can see the light at the end of the tunnel where I'm going to be able to, declare victory, but, when I'm when I'm in my hot tub staring at the sky, I sometimes play with that idea.
And you going forth and doing this, that vision of you in the hot tub looking up and seeing the light, stroking the beard, and okay. So now let's talk about what this is going to look like, because this is also really important to figure out. So if I am 40, 50 and we're getting these rejuvenations, how does the economic and political, sociological sphere change?
So one thing I really want to do, really want to do in the next year is get in the face of proper policymakers and opinion formers who can actually move the needle with regard to preparation for the transition that's going to occur. Because it's desperately urgent. Yeah. The reason it's desperately urgent is completely not understood, even though I've been saying it for a long time. The reason it's not understood is that people think, well, okay, these therapies may come along at some point in the future, but we're going to have a nice lot of warning. There's going to be plenty of lead time before the therapies come along. We're going to be able to figure out what to do. People think, well, that's good enough. We're paying attention to all the studies that are going on in mice and in the labs. We'll get the idea. But it's not true. The fact is that that's not what policymakers and opinion formers should be looking at. Yes, it certainly is true that there will be a significant lag between the point where we have enough proof in the laboratory that rejuvenation is going to work and the point where we actually get it to work in humans. There's plenty of lag there, at least a decade. Sounds great. But the societal changes that are going to occur are going to happen at the first of those points, not the second one. What's going to happen? Think about it. Supposing you woke up tomorrow morning and you read in the papers that it wasn't just this crazy English guy with the beard, but actually the consensus, the center of gravity of expert gerontological opinion had become that, yes, Aubrey de Grey was right all along, that, we will get this rejuvenation thing to work. It's only a matter of time. That's what's going to happen. There's going to be a point where that's going to happen, where the literally less than a dozen people who really control opinion on this, the top level of acknowledged experts in this area, come to the conclusion that, yeah, rejuvenation is going to work. Now, and they come to the conclusion sufficiently strongly that they're willing to say it on camera. Okay, that's the point. When that happens, think to yourself, what is going to happen to you? What are you going to do next? One thing you're going to do is you're going to wonder whether your premium on your life insurance is as low as it ought to be. You're going to think about your health insurance. You're going to think about inheritance. You're going to think about pensions. You're going to think about all of the things that flow from your historic assumption of roughly how long you're going to live, right? When that day happens, that assumption is going to be turned completely upside down that day. And everybody is going to be watching the same television on the same day. And if policymakers and opinion formers are not ready for that, need I say more? You know, it's going to be complete fucking pandemonium. And it doesn't matter whether it's going to be 10 years or 20 years or 100 years, but from that time to the point where we actually do get these therapies working in humans. So this is completely independent of the spectrum, the very legitimate, reasonable spectrum of opinion that exists in the expert community with regard to just how hard it is to get from mice to humans. Completely independent of that. Chaos. So that's why I'm in a hurry to talk to these people.
And what would you talk to them about? What are the policies that you think are best?
Well, they come at several levels. Firstly, on the research, there is going to be, I mean, you thought the war on cancer was not much of a big deal. You're right, it wasn't much of a big deal. It was a trebling of the, National Cancer Institute budgets, and it definitely made a significant difference to the rate of progress against cancer. But it was imperceptible to the, to the US public, as a proportion of the budget, right, of the national budget. That's not going to be like that. This is going to be actual wartime kind of scenario. This is going to be a case where people are completely, not just willing, but they want to accept a substantial, as required, diminution, temporarily of course, of their standard of living just in order to end the slaughter as soon as possible. Okay? And that will translate, of course, into policy at once. It'll be just completely impossible to get elected unless you do that, right? But that's the easy part. Throwing as much money as you can imagine, or certainly as much money as needed, at the research. And of course, there are diminishing returns in that. There's only so fast you can find things out and get things to work. Even the Manhattan Project took some time, right? So that's part of it. But that's the easy part. The more expensive and more interesting part is all the other preparation. The preparation for the point at which the therapies do come online. Number one, simply having the infrastructure, the number of hospitals and the medical personnel to be able to provide all these preventative therapies to people who are old enough to need them, which is a lot of people, right? A lot more than the already really rather large number of people who are sick today, right, because of aging, right? Then all the restructuring that's got to be done in terms of pensions, as I mentioned already, and insurance and so on. Restructuring the medical industry. The industry, any industry, is an ecosystem of people who all have their own vested interests. They all need to make money. You've got to make the ecosystem work. You've got to provide the right kind of legal structures, the right kind of incentives, the right kind of subsidies. All of this has to be actually, as such, worked through, right? And then, I haven't begun to, on all the other stuff that we need to figure out, like, accelerating the development of things to reduce the carbon footprint of the average person so that overpopulation doesn't matter, or, accelerating the introduction of automation so that work doesn't matter and we can forget about pensions and so on. There's quite a lot. And let me explain. It's not as if I claim to be an expert on all of this. I am just a recreational demographer, a recreational economist, I am just out there giving people the substrate with which to do their jobs. And they're not fucking listening, and that's pissing me off.
And there's a lot of implications for us in just the simplest way of what are we going to do with our time if we know that we're not dying when we're 80?
Okay, look, let me explain.
What do we do?
In fact, let me quote my good friend Brian Kennedy, who said this on stage when I was sitting next to him and we were doing some debate or other. He and I were on the same side. We were debating some bloody philosophers. Someone said that kind of thing. And he said, well, look, if I've got the choice of being bored at age 150 or getting Alzheimer's at age 80, I think I know which one I'm going to choose, and I think I know which one you're going to choose too. So, I mean, get a fucking sense of proportion. I mean, how hard is this to understand? This is from the idea that I was coming out of. When are we going to choose to have kids? We're not going to need to have children until later. We're going to have more time to do things. I'm not saying these questions are infantile. Of course they're sensible. The problem is that people actually get hung up on the question. Yes, absolutely. It would be nice to think about and speculate about how often one would have kids and what one would do at one time if one could spend all one's time staring at the sky from one's hot tub Now, that would be nice. You know, I would like that kind of problem.
More time to be creative and start more businesses.
You don't say. Yeah, I mean, whether there will be any things called businesses anymore. You know, more time to enrich each other's lives. That's how I look at it. Right?
Good way to put it.